join me in welcoming Professor Massey.
Thank you, Karen, and thanks to the conference organizers for having me. I'm going to talk about some new research today on the NFL draft, skill versus chance in the NFL draft. And I want to say right up top that there clearly is skill in the NFL draft. By any measure, players taken at the top of the draft perform better than players taken later in the draft. So consider only starts, the number of starts a player has in the league. And what we're doing in this curve is just following those number of starts from the left-hand side early in the draft to the right-hand side late in the draft. And there's a very steady decline in the number of starts that a player will have in the league as a function of where he's drafted. So what we have on the y-axis here is just relative to the number one pick. How many starts does this player typically have? These are numbers that are collected over about 15 years worth of drafts. And you see that the 65th pick, which is the first pick in the third round, the 65th pick is about half as many starts as the first pick in the draft. So this steady decline looks like some skill must be involved to get that kind of decline. You can look at other measures as well. Pro Bowls. Consider Pro Bowls. There's an even steeper decline in Pro Bowls. So clearly there is a relation between the talent in the player and where he's drafted. If you're worried about these stats because they're kind of coarse, you can go to some trouble and build a fancier performance measure. In some previous work that I've done with Thaler on the loser's curse, we jump through all kinds of hoops. We go to the free agent market to use salaries to tell us how much performance at different levels is valued from different positions. We come up with a very sophisticated, continuous, fine, convex measure of performance. If you throw that curve up there, it looks almost exactly like starts. So this is something we've seen for years, and this actually tells us that we can use starts as kind of a heuristic for performance value in a player, and all of them decline. So clearly there's some skill in the draft. But the claim today is that that's too low a bar. We're not interested in whether the third-round pick is better than a fourth-round pick. We're not impressed with teams whose second-round picks are better than their third-round picks. And also, teams aren't worried about this. Teams aren't sweating whether their second-round picks are better than their third. Teams are sweating which of three cornerbacks to take in the first round. And fans are kvetching about their team's ability to identify which of two quarterbacks to take. So it's those closer decisions where we actually see skill in the draft that we care about, and it's those closer decisions we want to look at today. So the question is, clearly there's skill, but are there differences in skill? And in particular, are some teams better than other teams at picking players? So let's look at some data, some more data. These are just the number of Pro Bowl seasons by players drafted by each team. This is over an 11-year period. And it just adds up, literally, the number of Pro Bowl seasons by players drafted by each of these teams. You see Indianapolis leads the league in this period with 37, and it drifts all the way down to Cleveland at 7 and Detroit at 4, and it looks like there are these huge differences in the ability to draft players. And these data actually come from a Rick Riley column, an ESPN Rick Riley column last spring, where Riley said some very smart things about the draft, but then he brings up these numbers and he says, well, look, if you give it enough time, you can look at the data and you can see where the real differences are. And here's Indianapolis doing great. Here's Cleveland doing bad. This is what Riley says. He says the Colts, not just Manning, but Dwight Freeney, Edgerrin James, Reggie Wayne, these were genius picks. And of the Browns, he says they screwed the Chihuahua. He says their run of number one picks from 99 to 2002 is the single worst stretch of drafting since the Iraqi Republican Guard. Were they using a Ouija board? And, you know, I think this is representative of many opinions. He's not unique in having this opinion. And moreover, he's basing it on some data, so it seems reasonable. But I'm skeptical. I'm skeptical for two reasons. One is previous research on the NFL draft. So this research I was just referring to with Thaler on the loser's curse, we asked, the first statistic we ever looked at in that research was, what's the probability that a player taken in the draft is better than the next player at his position taken in the draft? So, for example, the third cornerback in the draft versus the fourth cornerback in the draft. So they may not be drafted right next to each other. Maybe they're drafted, 22nd and 27th. On average, they're about 7 positions apart. But I'm asking, at any position, 2 adjacent players, the second offensive tackle versus the third offensive tackle, the first quarterback versus the second. What's the probability that the first player is better than the second player? So I'll show you those data. I'll show you for each round in the draft, but it doesn't really matter because it's all real steady right around 50%. The average is 52%. So it's slightly above chance, but it's only slightly above chance. And so given that kind of uncertainty, I'm a little skeptical that we actually have that much difference in ability to identify which of these two players is going to be better and pick that player. The other reason I'm skeptical is a long tradition in psychology research that says that people underappreciate the role of chance. So for example, they believe in this law of small numbers. The law of small numbers is this notion that small samples, 2, 3 observations, should be representative of the underlying skill or the underlying population. Now this is true of large samples. It's not true of small samples. Because of noise, small samples are going to bounce around a great deal. One example of people not appreciating the role of chance, well, it leads to a problem that Matthew Rabin, who's one of the top behavioral economists around, Matthew Rabin has called it fictitious variation. And the notion of fictitious variation is that if you observe differences in performance, you can make one of two attributions. You can believe that's because there are differences in skill, or you can believe that's because there are differences in luck. And if you don't appreciate the role of chance, the role of luck, then you're going to attribute too much of that to differences in skill. Rabin points out that even if people are completely average, everybody in a population is the same, because of chance, there's going to be differences in performance. And because people don't appreciate the role of chance, they'll come to believe that there are actual differences in skill, even if they have exactly the same underlying difference in skill. So this is this notion of fictitious variation. It's actually not been tested. It's very well founded in psychology, but it's not been tested. It's going to lead to our hypothesis for this research, which is that there's less difference in draft picking skill than people actually believe. And how are we going to test that? We're going to test it using these starts, this simple statistic of the number of starts that a player has in the NFL as a function of when he's drafted. And we're going to adjust for draft position. You have to do this. It's kind of like evaluating mutual fund managers. If a mutual fund manager tells you that he earned 10% on his fund last year, are you impressed? You probably are last year, right? That's not bad. But what do you need to know? You need to know how the market did. Right? If the market was 8, then maybe you're impressed. If the market was 12, you're not impressed. You're going to adjust for what the market did. So same with us with these starts. If I tell you a player has 10 starts in a year in his career, are you impressed with that draft or not? Probably impressed, but what if he's the first pick in the draft? That's actually under average, it's below expectations. So we're going to make those adjustments. I'll show you what that looks like in a moment. We're going to use the player's first 5 years. This is a remnant of earlier research. We're often interested in the returns to the team that drafted the player, but it doesn't matter. You can run it out over his whole career if you want to. And we're going to do 2 tests. We're going to look within a year across all teams. Do we see differences across teams within any given draft year? And then we're also going to say within a team across years, following a single team across years, do we see evidence of skill? So 2 different ways of doing this. This is what I mean by adjusting a pick for expectations. This is the number of starts per season. It's the same curve I showed you up front. And this time I have the actual number of starts. And so the first pick in the draft averages 11 starts per season over his first 5 years. And that drops, again, the 65th pick in the draft, the first pick in the 3rd round, that drops to about 6 at that point. Steady decline. So every pick in the draft, we want to adjust for this expectation. This is based on 15 years of data, 15 years of drafts. So here's an example. This is the New England Patriots 2003 draft. I thought I'd use a local team and show you how we code each of these picks. So what I've shown in red there are they had 10 picks, typical New England, 10 picks in this draft. And each one is represented there by the number where he was drafted along the x-axis, and then the number of starts per season in his first 5 years on the y-axis. And then with those long lines are the difference between expected number of starts and actual number of starts. So what do we see? We see Dan Coppin, longtime center, another local kid, Boston College player, came out and he was expected, 6th round pick, expected to play get about 2 starts a year. What'd they get out of him? 14. So this is a big plus, even though he has about the same number of starts as Ty Warren. He was drafted so much later in the draft that we're going to give the Patriots more credit. So this is what I mean by adjustment. We're just adjusting for expected at that position. And we're going to do this for every team every year. So what are we looking for? If there is skill, what would that picture look like? If there's skill, these picks should tend to move together. They're going to typically be, not exactly together, but tend to move together. They'll be above the line for good teams. They'll be below the line for bad teams. If there's skill, they will move. They'll cluster like that. If there's no skill, if it's all chance, it's just going to be random fluctuations around that expected line. That's essentially the test that we're going to run. So this is what it looks like. This is one team, 1 year. Now we're going to drop that into all the teams for a given year. So this is a picture of what that looks like in 1995. I'm going to take those. Let me refer to these as these are residuals in a way. This is residual versus expected. You can take those residuals and drop them in for every team. So this is just 1995. It's only half the teams because that's an easier thing to show you. But then every column there is a team. So look at Green Bay. Green Bay is about 2/3 of the way down. They look a lot like that picture I just showed you with New England because they have 5 picks above, I think that's Green Bay, 5 picks above the line. New England's draft was quite good that year, so I'm giving you one that looks kind of like that. They had 5 picks above average. They have 3 or 4 picks below average, but on balance, that was a pretty good year. The residuals are generally positive. And we do that for every one of these. So the first line, Arizona, they have 6 picks, 3 are below, 3 are above. We're doing that for every one of these teams. And the question is, do they tend to move together as a team? Do you tend to see a team that's either good or bad, or the picks are kind of tightly clustered around that basic skill level? That's what it would look like if this was a skill-driven process. Or conversely, is it just random around the middle line? It's just random around expected, and there's no true differences in skill across the teams. That's the test we're basically going to run that. So running that test is called an interclass correlation, and it can range from 0 to 1. If all of the variation we observe comes from differences in skill across the teams, that interclass correlation is going to be 1. If none of the variation comes from differences across teams, it's all just noise, then that interclass correlation is going to be 0. So, and we can do that. We run a separate one for each year. We have 16 years worth of these drafts. We can run a separate test. It gives us dice. We can run 16 different tests and see how does that thing move around. Do we see much variation explained by skill? These differences in skill across teams. This is what that looks like. 16 years worth of interclass correlation coefficients, possibly ranging from 0 to 1. What does it look like? They are all statistically 0. So the largest one is in 1995, which is the picture that I showed you, and that 5% of the variation is explained by differences in skill across teams. 95% is just noise within a team. Every year half the years are actually estimated at 0. Every year is statistically 0. So I expected this thing to be low. I thought there was less than people believed. I didn't know that it would be this low. This is saying that there are no differences across team, 0 differences across team, literally. 0 differences across teams in player picking ability. So pretty stark. This test is a little tough to get your head around, right? This is why I've not done this kind of analysis before. Let me give you an easier analysis. This was same year across team. I'm going to give you one that's same team across years. It's a little bit more straightforward. So what we want to do is, it's kind of like the way they look at mutual fund managers. You say, how do the top managers compare in 1 year? How does the performance of the top managers in 1 year compare to their performance the next year? So that's what we're going to do with the drafts. We're going to take the same residual we've been talking about and divide every team in a year into quartiles. The top quartile, according to that measure, the one who had the players with the most starts relative to expectations. Second quartile, third quartile, fourth quartile. So this is what that looks like. And again, the x-axis is always starts. In this case, it starts relative to expected. As we showed you that line, we were backing off of every pick. What this says is that the top quartile, in any given year, the top quartile of teams averages almost 2 starts per player per season more than the average team. It's pretty nice. Bottom quartile, almost 2 starts per player per season, worse than average. So that's a pretty big spread. So consider the difference between the top quartile teams and the bottom quartile teams. 4 starts per player per season. That's a huge difference in draft success that year. It's like that picture I showed you, the Rick Riley picture I showed you up front. Huge variation in quality in any given time slot. You can take any year and divide it. It looks like this. This is across all the years in our study. Big differences across year. The question is, does it persist? If this is skill, if it's purely skill, We're going to ask what happens the next year. If it's purely skill, you'll see the same numbers. It should transform exactly. The top quartile this year, they average 1.5, 2 games above average. They'll have 1.5, 2 games above average the next year, if it's purely skill. What happens if it's purely chance? If it's purely chance, if only luck drove those numbers, all those numbers will go away to 0 in the next year. If it's something in between, if it's some mix, you'll see some regression to the mean. So to give you an example, what do won-loss records look like? If you look at won-loss records in the NFL, you can do the same analysis. What happens? It goes somewhat down. There's some regression to the mean. Doesn't go all the way, though, because there's some persistence and ability. But it's not perfectly persistent. So that's all we're going to do with these draft success. We see big discrepancies in any given year. Is that the result of luck, or is that the result of skill? This is one way to look at it. What do we see? It goes all the way to 0. This, in fact, it turns over a little bit. So for those of you who are interested in these kinds of things, the autocorrelation is actually a little bit negative. It's not reliably different from 0, but it's negative 0.14. But essentially, it just goes to 0. So this is a different way to test this, right, than the interclass correlation, but the result is just as stark. It, again, is starker than I expected it to be. I thought it would be low. I didn't know that it would be 0. It goes to 0. It says that chart that Rick Riley used in his column last spring is 100% driven by chance. That, of course, you're going to get discrepancies. In any given process, you can lay out the winners and the losers, but the question is it luck or is it skill that got them there? This is telling us that it's luck, 100% luck. It's really quite stark. Again, 15 years worth of drafts. So it's all chance on the margin. Is this a nihilistic observation? Is this a nihilistic claim? Are we supposed to just throw up our hands, I guess, is one of the questions. And one of the reasons I ask this is because if you talk about this with a team, they can almost not entertain the observation because what are they supposed to do with it? But I do think there's a lot to do with it. And so this is what, in my remaining 5 minutes or so, I want to talk about what you're supposed to do with this. The idea is that your decision strategy depends on your situation. And let me divide the world into just skill-based and a skill-based versus chance-based continuum. And as an example, just consider math problems as kind of the canonical skill-based situation, and consider lotteries as the canonical chance situation. And the idea is you're going to go about your decisions differently if you're solving math problems than if you're entering a lottery. That's the simple claim. And of course, much of life is a mix. I'm going to use backgammon as a metaphor there, some chance, some skill. But the claim is you need to adapt your strategy to the situation. You need to have your eyes open about the situation and then adapt your strategy accordingly. So football, I didn't put it all the way, I don't mean football overall, I mean football in the draft. I didn't put it all the way to the right, but the stats kind of suggest that the draft should put it all the way to the right. But the idea is you're in a chance-driven situation. You should adapt your decision strategy accordingly. So let's talk about what that means. There's a logic of chance. The idea here is that there's a logic of chance. It's not just to throw up your hands, what can we do? You can do things. You should do things differently. There's a distinct set of prescriptions for operating in an environment with high uncertainty. So first is to acknowledge the role of chance. This is a problem for anybody who's an expert. You've been in a field 20 years, 30 years, 40 years, people you look to you for your opinion. It's hard to admit that you don't know. It's hard to admit that there's a limit to what you can know. And so the first step is to acknowledge the uncertainty. Happily, there are some good examples. I was surprised and pleased to see Roethlisberger, after they beat the Ravens this year. Sorry, Matt. They asked him, how is it that you guys have beat the Ravens so many times lately in these close games? What did he say? He said, we got lucky. It's an impressive attribution. Maybe he was being overly humble, but people do make these attributions on occasion. In fact, in Alex's panel earlier today, the football analytics panel, they talked about chance. Mangini talked about chance in his playoff run with the Pats the first year. Alec talked about chance and getting to work for an organization. So people do acknowledge this. It's a necessary first step. Second step is to maximize your number of chances. So the logic of chance is to maximize your number of chances. So here's variation in the number of picks that NFL teams had in the 2004 through 2008 drafts. So 5 years worth of drafts, average number of picks per draft. It ranges from the Titans at over 10 to Washington near 6. So 4 more picks per year for a 5-year run. That's 20 more draft picks by the Titans and the Redskins. Now, I don't know whether that was a philosophical decision. I know some of those teams at the top, Green Bay, Philadelphia, those guys have a philosophy about what they do with their draft picks, and it's more, not less. And Snyder has not had that philosophy in the past. But the logic of chance says, if you're in a chance environment, the optimal strategy is to maximize your number of chances. That's one of the first steps that you take. The logic of chance also says minimize the cost of choosing. So back to the mutual fund analogy, this is one of the reasons the finance professors and the finance experts tell you don't pay for mutual funds. There isn't persistent skill in the mutual fund industry, so you don't want to pay those fees. You pay for index funds, the cheapest thing out there. You minimize, in a chance environment, you minimize the cost. What's the analog in the NFL? It's how much does it cost to trade up in the NFL? So our favorite example, we've been talking about it since the day it happened, setting aside differences in quarterback ability, the Manning versus Rivers trade that the Giants made. So what did I tell you about the likelihood that any given player is better than the next player taken in his position? 52%. This is the first pick versus the fourth. It's the first quarterback versus the second. What did the Giants pay to choose Manning over Rivers, or to make that trade? They paid 3 players, all of whom made the Pro Bowl. That's expensive. That's a high cost of choosing. The logic of chance says, in a chance environment, you minimize the cost of choosing. Logic of chance says, value the process and protect the process. So here's a picture of the Steelers war room with some scouts. Will, we got some scouts in there for you. And these guys spend months building that draft board. And then in some clubs, in some years, on draft day, in the war room, that draft board starts changing. And they're undermining the work that the scouts have put months and months and hours into. And for what? The logic of chance says, look, it doesn't matter because any 2 players, it's chance. And so you have to start thinking, what else do you care about? You care about the motivation of your employees. You care about the process. You care about the thought that went into this. If you're in a chance environment, protect the process. The logic of chance says, seek broad, independent input. So the logic of skill says, find the smartest guy in the room and let him make the decision. The logic of chance says, nobody knows this. We need as many opinions as possible, and we need them to be as independent as possible. Again, back to the football analytics panel earlier today, they talked about the groupthink that sets in about the top 30 picks. Everyone's got the same top 30 picks. How can that be? It's because they don't have independent opinions. If you're in a chance environment, this is what Sir Ricky argued in The Wisdom of Crowds, and if you're in a chance environment, you need as many opinions and as independent opinion as you can get. Finally, the logic of chance says, be slow to place credit and blame. The logic of skill says, look what happens, fire the guys who screwed up and promote the guys who did well. The logic of chance says, look, there's a lot of noise here. We're going to do that eventually, but we're going to be slow to place credit and place blame. So my favorite example here is Bobby Beathard, fantastic general manager. He's given a lot of credit for many good decisions, including finding Darryl Green. Darryl Green played for Texas A&I in Kingsville, Texas. Hall of Fame defensive back. But Bobby Beathard also hired or drafted Ryan Leaf. So we probably gave Beathard the claim here, in a chance environment, the logic chance would say we're giving Beathard too much credit for Green and too much blame for Leaf. And you need to be careful about that when you're in these chance environments. So this logic of chance is just an argument that just because it's a chance process doesn't mean there's not an optimal way to go about it. And I've just spun through a few prescriptions that come out of how you should adapt your decision strategy when you're in a chance environment. So in sum, at the margin, picking players is chance. Teams don't vary at this. This is this interclass correlation. 16 years, no variation explained by differences across team. And there are no persistent differences in drafting ability. So even when you have a good year, it's followed by 0, essentially. So the picking players is chance, and the claim here is that managing chance is where the skill is. And I suggest that there is evidence that there are differences in skill at managing chance. But that's a different talk. So thank you.
Yes, I have a question about the slide that you had with the Pro Bowl appearances. How do you explain the extreme difference between the Colts, who had like the huge number of Pro Bowlers, versus the Detroit Lions? Like, if it's all chance, then how do certain teams excel?
You're in a chance process, you're in a random draw. Some people are going to go to the right tail, That's just what happens in the chance process. The question is that persistent? And I've cut the data every way I know how to cut it, and you just don't see any persistence there. But you have to recognize that that's what noise is. That noise will separate performance. That you have to be careful about how you interpret that separation.
Right.
Fictitious variation. That's the line from Matthew Raven. Fictitious variation.
Excuse me. Can I give you to flip back to the slide where you had the graph for the value of the expected number of starts across different picks? Or maybe you don't have to flip back to it, but basically my question is, when you compute the expected, I guess, number of starts for a given draft pick, do you account for the fact that players who are joining a better team are more likely going to have fewer starts the next season? So maybe, as an alternative hypothesis, you could consider a world where certain teams like the Colts and the Patriots just draft better every year, are a better team every year, and they have their better players, but they start the same amount because those better players are coming into a better team.
It's a good question and a fair question. I've looked hard for that kind of effect in my previous research, and we've tried to control for that previous research. I don't, and for a couple of reasons. One, remember we're looking continuously throughout the draft. So this is also, the guys at the top of the first, at the bottom of the first versus the top of the second. So the thing obviously, at any point in the draft, you can look up to teams that are worse than you, but you can also look down to teams that are worse than you. The other thing to keep in mind is how much regression to the mean there is in the team performance. So the teams don't stay up very long in the NFL. Teams churn quite a bit. In fact, I don't know that 2 years ago your record explains this year's record. If it does, it barely does. Last year's does. 2 years doesn't. So things turn pretty quickly. And the circuit turn way within those 5 years that I'm using in mind. Alex.
So, Cade, is there a chance that we should spend more time trying to make skill a part of this, or should you just give up on it? Are you saying give up on it, or are you saying there's a real opportunity here for someone to make skill a broader part of the equation?
So Alec is obsessed with explaining more of the variance. He wants to understand how to find that quarterback. How can we better predict which quarterbacks are going to be, which is a noble pursuit. But and yes, it's worthwhile, but know what the limits are right now. And what you want to, this is one of the first steps, is to understand the limits of what you know. So keep on trying. But what happens is that people believe they've figured it out before they have evidence that they've figured it out. And so they start acting on that and paying a great deal to take one guy over another guy, but they don't have the evidence. And year after year after year, it turns out they haven't figured it out. It doesn't mean to give up, but there are limits to what you can know. And that's the way chance works. That's the way the world is noisy. There are going to be limits. But no, keep on looking, absolutely. Just recognize that when you're there, when you're not there.
We should fire Will right now.
Not now. Not in Boston.
Just pro scouting.
Yes. Down in the back.
Very, very, very interesting analysis. Great job. Very good stuff. So it kind of strikes me that because we're benchmarking a lot of these players, in some ways what we're saying is that around what our expectations are for folks like that, there's just variation, right? Which in some ways kind of says, well, if we get a bunch of smart people trying to predict the outcome of this system, we kind of get roughly what we would expect, right? It's kind of saying, like, if you're high in the draft, you're going to start more games. There's variations around how, et cetera, et cetera. So one of the things which it may not necessarily, or have you looked at, okay, if I'm drafting at this slot, I'm paying a player this amount, and this is how many games they're going to play. Because in a salary cap world, you have an allocation decision that you really need to make. Have you looked at that at all, or do you have any thoughts on kind of issues you would see with that, or how you'd use it?
Your thinking is exactly right, and that's where I started in this world of research, was on that question. And that was the first paper I did with Baylor on the loser's curves. Does that analysis. And our conclusion from that paper was even more surprising to us than this conclusion is to me, because we looked at, once you concluded you compared the performance, the expected performance to the cost of those players, and then asked what's the real value of the pick. Instead of the value going down as you go through the first round, the value actually goes up. So that the first pick in the first round, once you consider performance and cost in the salary category, the first pick in the first round is the least valuable pick in the first round. And we thought that it would go down just not that quickly. It actually goes up. But that's previous research that we did a few years ago.
Not having your paper handy with me, can you just give us a brief thumbnail, like what's kind of the sweet spot of where you want to be within, say, the first 100 picks in the NFL?
So it peaks, this thing, it just goes up and comes back down and peaks up, depending on how tightly you parameterize this thing. It's like end of first round, early second.
Got it.
And you can easily find that thing out there.
Thank you.
Do you feel that the ability of a coaching staff to cultivate talent quicker than some other coaching staffs, does that factor in at all into the number of Pro Bowl appearances?
It's a great question, and I'm sure it does, and that's beyond our data altogether. And it's one of the logic of chance says the game's not over when you made the pick. It's all about filtering out and cultivating, and it's putting more emphasis on filtering out and cultivating, and we just don't have the data. It's a great question. I'd love to hear from teams about that. Yes, over here.
Hi.
A residual for a first-round player, 2-game residual for a first-round player may be different than a 2-game residual for.
Yeah.
How are you going to deal with that? You dealt with it?
So it's different in a couple of ways.
In terms of winning games.
Yeah, absolutely. So I referred on the first slide to a few different performance measures. So it starts in Pro Bowls, and then this Massey Taylor value, which was our best attempt, and we jumped through a lot of hoops to do it, to value performance in dollar terms. And what that allows you to do is it allows you to get a very convex function, which says the best player in the league is like twice as valuable as the 20th player. It's very steep.
Number of variables that are there in a way that it's really hard to predict weather 2 weeks out, because there's so many things that can happen that you really can't predict. Do you think that's true? There's so many variables that people who are trying to draft just can't get their mind around all of the possible things, or is it something else?
It's interesting. There's a finding in psychology that shows that you give this is a classic finding in psychology. You give clinical psychologists. This isn't even like the typical psych study with undergrads. This is a study with professional clinical psychology. You give them a few bits of evidence and ask them to diagnose a patient, and they get it right some percentage of the time, and they're relatively confident. And then you give them a few more pieces of evidence, and they get it right a little bit more often, but their confidence goes up more. And then you give them a few more bits of evidence, and they don't increase their diagnosis at all, but their confidence goes up yet again. And I think that's part of what goes on in the NFL draft, especially the higher you are up in the draft. These guys get studied for months and months and months. They're just getting more and more and more and more information. We would expect from research in psychology that your confidence is going to outpace your ability to actually diagnose using information.
Following up on that, is there data on free agency and chance? Because one would assume once a player's in the league, you have more information, but from what you're saying, you would think the confidence in selecting free agents is even greater than your actual ability.
That's such a great question. Great observation. I think that's exactly right. So, you take teams that, we won't call anybody out, we might be in the room right now, but teams that sign all-pro wide receivers because they've had a couple of good years and they need an all-pro wide receiver, so they're convinced, well, this is a safe one. We'll trade some picks even to get this guy because he's an all-pro wide receiver. Once one, always one, right? But that's not the way it works. But we haven't done that analysis. It's a great question. It's a strong claim would be that there's more chance there than people who shoot. Yes, we'll do 2 more questions.
I'm wondering if you or others have looked across other sports, baseball being a good example of one where you may have so many more data points. You have 40 years, you've got 2,000 people, you've got more granular metrics for success, win shares, stuff like that. Are you aware of other studies, and do you think it's persistent across leagues?
It's a fair question, and I don't know anything about in baseball in particular. I know some guys have replicated some of this, especially the earlier stuff with Taylor that's been replicated in basketball. Many people thought it wouldn't go through in basketball because performance is more observable, it's a smaller team, that kind of thing. But it turns out that people overvalue draft days, not as extremely as they do in football, but they do in basketball. So, for example, Cade Massey, who talked this morning and has the new book on scorecasting, as part of his book and all of his research, he replicated this he replicated that in basketball. Baseball, I'm not so sure. I think Alex's question earlier is relevant here. The challenge is you always have to recognize that even in baseball, the R squared of those models is going to cap out somewhere depressingly low, right? Just say it's 50 or 60%. You're not going to explain all the variants. You're drafting, especially here's the downside of baseball. You're drafting high school players, right? So in some ways, you've got this deeper growth than you do in high school. And so you've got deeper projection in some way. And I don't know it well enough, but I've got a strong suspicion that people are reluctant to accept the limits of those models. Even with those much better data, they're reluctant to admit how little they can predict. Thank you guys very much. Appreciate it.